power plants. These often imposing structures, sometimes tucked away in remote locations and sometimes dominating the landscape, are the beating heart of our civilization, silently and tirelessly generating the electricity that powers our homes, businesses, and industries. Without them, our world would grind to a halt, plunging us back into a pre-industrial era. Imagine a world without the soft glow of light bulbs illuminating our homes at night, without the hum of refrigerators keeping our food fresh, without the countless electronic devices that have become indispensable to our daily lives. This is the world that power plants have saved us from. They provide us with the energy we need to live, work, and thrive. From the moment we wake up to the time we go to sleep, we are constantly reliant on electricity. It powers our alarm clocks, charges our phones, heats our water, cooks our food, and entertains us through televisions, computers, and countless other devices. Electricity has become so deeply integrated into our lives that we often take it for granted. Yet behind this invisible force lies a complex and fascinating world of engineering marvels, scientific breakthroughs, and environmental challenges. The history of power plants is a testament to human ingenuity, our relentless pursuit of progress, and our growing awareness of the need for sustainable energy solutions. Power plants have evolved significantly over the years, from the early days of coal and steam to the modern era of nuclear, wind, and solar energy. The journey has been one of constant innovation and adaptation. Today, we are more aware than ever of the environmental impact of our energy consumption. This awareness drives the development of cleaner, more efficient technologies that aim to reduce our carbon footprint while meeting the growing demand for electricity. Renewable energy sources like wind and solar are becoming increasingly important. They offer the promise of a sustainable future, where we can harness the power of nature to fuel our modern lives without depleting the planet's resources. The transition to renewable energy is not without its challenges. It requires significant investment, technological advancements, and a shift in how we think about energy production and consumption, but the potential benefits are immense. A world powered by clean, renewable energy would be healthier, more sustainable, and more resilient. It would ensure that future generations can enjoy the same comforts and conveniences that we do today. As we continue to innovate and push the boundaries of what's possible, power plants will remain at the forefront of this energy revolution. They will continue to be the heartbeat of our civilization, driving progress and powering our future. So the next time you flip a switch, charge your phone, or enjoy a hot meal, take a moment to appreciate the incredible infrastructure that makes it all possible. Power plants are more than just industrial facilities. They are the lifeblood of our modern world. Power plants convert various forms of energy into electrical power. The most common types include thermal power plants, which burn fossil fuels like coal, natural gas, or oil to produce steam that drives turbines connected to generators. In nuclear power plants, nuclear fission generates heat to produce steam, which then drives the turbines. Hydroelectric power plants use the energy of falling or flowing water to turn turbines. Wind and solar power plants harness natural forces. Wind turbines convert wind energy into electricity, while solar panels convert sunlight directly into electrical power through photovoltaic cells. Each type of power plant has its own set of technologies and processes, but they all share the common goal of generating electricity to meet our needs. As we continue to innovate and push the boundaries of what's possible, power plants will remain at the forefront of this energy revolution. They will continue to be the heartbeat of our civilization, driving progress and powering our future. The quest to harness energy from nature is as old as civilization itself. From the earliest days, humans have sought ways to make their lives easier by utilizing the natural forces around them. This journey began with the simple yet ingenious use of water wheels and windmills. For millennia, humans relied on simple machines like water wheels and windmills to grind grain, power mills, and perform other tasks. These devices were marvels of their time, transforming the kinetic energy of flowing water and wind into mechanical energy that could be used for various purposes. The invention of the steam engine in the 18th century marked a turning point in the history of power generation. This revolutionary technology harnessed the power of steam to drive machinery, opening up new possibilities for industrialization and mechanization. One of the earliest examples of a power plant was built in 1882 by Thomas Edison in New York City. This plant, known as the Pearl Street Station, was a pioneering effort in the field of electricity generation and distribution. The success of Pearl Street Station sparked a revolution in power generation, leading to the construction of similar plants in cities across the globe. This marked the beginning of the modern era of electricity, where power could be generated in one location and distributed over vast distances. The widespread adoption of electricity in the late 19th and early 20th centuries transformed society. Electric lights illuminated homes and streets, replacing dim and dangerous gas lamps, and making urban areas safer and more vibrant. The early 20th century saw the rise of coal as the dominant fuel for power generation. Coal was abundant, relatively inexpensive, and had a high energy content, making it an ideal fuel for large-scale power plants. The development of more efficient steam turbines further increased the efficiency of coal-fired power plants, making them the preferred choice for meeting the growing demand for electricity. As cities grew and industries expanded, the demand for electricity soared. Power plants became larger and more complex, with some generating enough electricity to power entire cities. The construction of massive power lines enabled the transmission of electricity over long distances, connecting rural communities to the electric grid, and facilitating the growth of industries far from urban centers. The rise of coal-fired power plants, however, came at a cost. The burning of coal released large amounts of pollutants into the atmosphere, including sulfur dioxide, nitrogen oxides, and particulate matter. These pollutants contributed to acid rain, smog, and respiratory problems, raising concerns about the environmental impact of coal-fired power generation. To understand how coal-fired power plants work, let's break down the process. First, coal is burned in a boiler to produce steam. The high-pressure steam then drives a turbine connected to a generator, converting thermal energy into mechanical energy, and finally into electrical energy. The steam is then condensed back into water and returned to the boiler to start the process again. In the mid-20th century, natural gas emerged as a cleaner alternative to coal for power generation. This shift was driven by the need to reduce the harmful environmental impacts associated with coal, such as air pollution and greenhouse gas emissions. Natural gas power plants emit significantly fewer pollutants than coal-fired plants, making them a more environmentally friendly option. The reduction in sulfur dioxide, nitrogen oxides, and particulate matter has been particularly beneficial for air quality. The abundance of natural gas reserves, coupled with advances in drilling and extraction technologies, led to a surge in the construction of natural gas power plants. Hydraulic fracturing, or fracking, has played a significant role in unlocking vast amounts of natural gas from shale formations. Natural gas power plants operate on a simple principle: burning natural gas to heat water, which produces steam that drives turbines connected to generators. This process is highly efficient and can convert a large percentage of the fuel's energy into electricity. These plants are highly efficient and can be brought online quickly, making them suitable for meeting peak demand for electricity. Their flexibility and reliability have made them a crucial part of the modern energy grid. Moreover, natural gas burns more cleanly than coal, emitting fewer greenhouse gases and other pollutants. This cleaner combustion process results in lower carbon dioxide emissions per unit of energy produced. The shift towards natural gas has had a positive impact on air quality in many parts of the world. Cities that once struggled with smog and pollution have seen significant improvements in air quality. The reduced emissions from natural gas power plants have contributed to a decrease in acid rain, smog, and respiratory illnesses. This has led to healthier communities and a better quality of life for many people. However, natural gas is still a fossil fuel, and its extraction and transportation can have environmental consequences, including methane leaks, which contribute to climate change. Efforts are ongoing to minimize these impacts through better technology and stricter regulations. The discovery of nuclear fission in the 1930s opened up new possibilities for power generation. Nuclear power plants harness the energy released from splitting atoms, promising a nearly limitless source of clean energy. These plants rely on a process called nuclear fission, where the nuclei of uranium atoms are split, releasing tremendous amounts of energy in the form of heat. The heat generated from fission is used to produce steam. This steam drives turbines, which in turn generate electricity. Nuclear power plants are highly efficient and produce very little air pollution, making them an attractive alternative to fossil fuel-powered plants. However, nuclear power has also faced significant challenges. the risk of accidents, such as the Chernobyl disaster in 1986 and the Fukushima disaster in 2011, has raised concerns about the safety of nuclear power plants. Additionally, the disposal of radioactive waste remains a major environmental challenge. As the world grappled with the challenges and potential of nuclear power, the quest for sustainable and environmentally friendly energy sources continued. Enter the age of renewable energy. From the vast solar farms that harness the sun's power to the wind turbines that capture the energy of the breeze, renewable energy sources have emerged as key players in the global energy landscape. Solar power, derived from the sun's rays, offers an inexhaustible and clean source of energy. Advances in photovoltaic technology have made solar panels more efficient and affordable, enabling widespread adoption. Wind energy, harnessed through towering turbines, has become a significant contributor to electricity generation, especially in regions with strong and consistent winds. Hydropower, one of the oldest forms of renewable energy, continues to play a crucial role in many parts of the world. By utilizing the kinetic energy of flowing water, hydropower plants generate electricity without emitting greenhouse gases. In addition, geothermal energy, which taps into the Earth's internal heat, provides a reliable and constant source of power. While renewable energy sources have their own set of challenges, such as variability and storage, innovations in technology and infrastructure are paving the way for a cleaner and more sustainable future. As we embrace these renewable sources, we move closer to a world where energy is abundant, clean, and accessible to all. Thank you for watching this video by Adeptis Academy. We hope you found it informative and engaging. Stay tuned for more educational content.